All right, so welcome to the sine ratio of a right triangle. Normally when you do trig functions, you do all of them kind of at once, but because we're sort of in a situation where we're taking things a little bit more slowly, I'm going to do a video for just sine ratios, and this is ratios. Now what you do with these ratios is you can use them to find angle measures, and then if you have an angle and are missing a side, you can use them to find missing side measures. But for now, we're just going to talk about setting up the ratios, right? Baby steps. But I'm going to do a sine video, a cosine video, and a tangent video. All right, so this first one is sine ratios of right triangles. Okay, the right triangle aspect is really important because you don't use the ratios generally without a right triangle. All right, there are other trig-related things that you can do when it's not a right triangle, but when it's a right triangle, we're just going to use the ratios. All right, so the way that the sine ratio works is it looks like that. It looks like the word sine. When we write it mathematically, we drop the E off, we shorten it, and even though it looks like the word sin, we still say sine. What would go right here is the angle that you're talking about. Generically, we use this little guy that looks like a kind of a circle with a cross through the center of him. That's a theta. But it doesn't have to be a theta. You could say sine of angle A. You could say sine of angle B. You could say sine of angle C. You could say sine of any angle that you want. When I do practice problems today, we're not going to use the theta. We're going to actually use A, B, or C because we're going to actually be looking within a triangle and at its angles. But don't be surprised if you see this theta. This theta just means whatever angle you're talking about. All right. So the sine relationship and the cosine relationship and the tangent relationship can be remembered using this idea of SOHCAHTOA. There is a shorthand to memorize them. It is some old hippie caught another hippie tripping on acid, but because you are working from home, you don't need to memorize this. You should have paper that you can write this down with. So I'm not going to have you memorize what sine, cosine, and tangent stand for. Just know, though, that we're going to use this piece. So I have that the sine of an angle is equal to the opposite side over the hypotenuse. Now, until you have a right triangle, this isn't going to do a whole lot for you. So let's go ahead and let's draw a right triangle. I know it's right because I put the little thing in the corner, or if someone says to you it's a right triangle, then you can believe them. I'm going to call this angle A, this angle B, and this angle C. And then I'm going to give it some side measures. They should work out nicely with Pythagorean theorem, so I'm going to use a really, really basic Pythagorean triple. Okay, so I have 3 side measures that measure 3, 4, and 5. Now, all we're doing is we're setting up a fraction. So all I want to do is I want to pick an angle, and then I want to compare its opposite over its hypotenuse. So I'm just going to write a fraction. Now, what I always like to do first is I like to identify the hypotenuse. Now, the reason for this is because the opposite side changes based on what angle you're looking at. So the first thing you want to label is the hypotenuse because the hypotenuse never changes. The hypotenuse is always the longest side, or if you can't tell it's the longest, it's always opposite the 90-degree angle. So when I look in this picture, here's my 90-degree angle. What side is across from it? It's this 5 right here. So this is my hypotenuse. You could also tell that because between 3, 4, and 5, 5 is the biggest number, meaning that it's the hypotenuse because the hypotenuse is always the longest side. All right, now we identify the angle we're going to use. Because in this particular problem, I could use a couple of different angles. I could look at the angle A. I could look at the angle C. You don't generally look at angle B because we already know how much that one measures. We know that that one measures 90 degrees. And if the whole point of trig is to initially find an angle measure, I don't ever need to find that 90 degrees, okay? So say I want to find sine of A. All right, I'm going to come over to A, and I'm going to kind of put a mark through it because that's the angle that I'm going to look at. And now, here's the part that's really important. Now that I know what angle I'm going to look at, I need to decide which side is opposite to that angle. All right, so you can't find the opposite side until you know what angle it is you're going to be looking for. Because if I'm looking at angle C, its opposite is different than angle A's opposite. So here's angle A. When I say opposite side, I mean all the way across the triangle from it, not touching it. So if here is A, see how A has 4 on one side of it and 5 on the other. Those are not opposite. Opposite is all the way across the triangle at 3. So this is my opposite side. Now, sine is always equal to opposite over hypotenuse. So all I do is I say sine of A equals the opposite length, which is 3, over the hypotenuse length, which is 5. And that's it. That's all I'm asking you to find for these initial sine, cosine, tangent problems, is can you find the ratio, the fraction of the opposite side to the hypotenuse side if it's sine. Okay? So now I'm going to go ahead. I'm going to erase this. All right? I'm on video, so if you need to write something down or draw something or take notes on this, you pause it and you do that. Because I'm going to erase this and we're going to do a couple more examples just to get you used to it. And then that's it for this sine video. All right? So I'll leave up this, but I'm going to erase the rest. Okay. Remember, I have office hours Monday, Wednesday, and Friday. So if you have questions, if you need actual like one-on-one teaching, then make sure you come to my office hours. All those instructions are in classroom. All right, so let's draw another triangle. And then with the sides, I'm gonna just label some numbers. Please bear with me. They're not gonna necessarily be Pythagoreanly correct because I just want you to get used to the idea of ratios. So like, don't come at me if you're like, oh, but miss, those don't add to, the hypotenuse squared. That's all right. We'll survive this. So I'm gonna say, I don't know, this one is 6, this one is 7, and this one is 8.5. You can have side measures that are decimals. You can have side measures that have things like radicals in them. You can have side measures that are already fractions. For the most part, I'm going to stick with really basic. Now, let's go ahead. I'm going to write that as sine of theta, because now I want to say, please find for me the sine of C. Okay? Sine is still opposite over hypotenuse. I'm going to look at this new triangle, and the first thing that I want to identify is my hypotenuse. The hypotenuse is the side that is the longest, and it's also the side opposite the 90-degree angle. So the side that's my longest and opposite my 90 is right there. That is always the hypotenuse. The hypotenuse is the hypotenuse is the hypotenuse is the hypotenuse. Opposite will change depending on the angle, but hypotenuse will always be hypotenuse. Now I need to decide what angle that I'm looking for. That's my angle C. And I need the side opposite this C. Now remember, opposite won't touch the angle that you've created. They'll be completely opposite each other. So I know 7 can't be opposite because it's right next to my angle. It's part of my angle form. I know it can't be 8.5 because I know that's already my hypotenuse. So my opposite has to be 6. So now all I do is remember it's opposite over hypotenuse. So my opposite measure is 6. My hypotenuse measure is 8.5. Now, what if I keep the same triangle? And now what if I ask you to find the sine of angle A? Now, the hypotenuse is still the hypotenuse, is still the hypotenuse. All right? It doesn't matter if I'm looking at C or if I'm looking at A. The hypotenuse is always the hypotenuse. But now that I'm looking at angle A has a different opposite. Okay, so that's why when you're looking at sine of something, you could have different, like if I just said you find the sine, you and someone else could have different answers because, kid, be careful. Sorry, one of my kids just came in the room and started to climb over cords. You could have different answers from somebody if you aren't paying attention to which angle you're each talking about. Okay, so be careful. All right, so what side is completely opposite A? It can't be 6 because 6 is next to A. It can't be 8.5 because 8.5 is the hypotenuse still. So the side opposite A is 7. So notice I now have two things labeled as opposite, but they're only opposite depending on the side and angle relationship. All right. When we look at cosine, we're going to talk adjacent. All right. Adjacent means next to. So generally in a triangle, if it's not an opposite side, and it's an adjacent side, but it depends on the angle. All right. So my opposite for A is 7. It's still opposite over hypotenuse, but what's my opposite from A? It's 7 over my hypotenuse, which is 8.5. Now, what you would do with this is eventually you could plug this into a calculator to get an angle measure. All right, you use a sine inverse for that. You could have the angle and use this to find a missing side if you were missing a side. But what's cool about trig is that it always gives you a way to find either a missing angle or a missing side using a relationship in a right triangle. Because as long as it's a right triangle, this sine relationship always works. Okay, so remember, I have office hours, so if you're like, I didn't totally follow that, let's do some examples together. Make sure you check my office hours. If my office hours don't work for you and you need some time, make sure you message me so that I can set up some time to meet with you when it works best for you. All right, I will hopefully see you in the next video for cosine.